Hello and welcome to R&D Man. Today I'm going to give you some hints for assignment 5.1 and 5.2 because they goes well together. Now let's have a look at 5.1. Here, first one, there is a positive correlation between teacher salaries and prescription drugs. So do you think? Well, you have to understand the concept of correlation. Now, just the idea here is just because two variables increase together, it may not mean that there is a relationship, right? So that's the idea behind correlation. Like raising of one variable, does it cause the other variable to raise or the other variable to decrease? So that's the idea behind that. So please read and answer that. For example, let's say students grade versus the number of hours they study in the morning and at night. So yes, there can be a correlation on that, right? There can be a relationship. So just because we have certain increase in two variables, it may not. So that's the idea. Please read it and answer. So that's part A. Part B, what variables might be causing the increase in, now in this case, think about this, teacher salaries and prescription drugs cost, they both increase, right? So it may be another case, for example, economy, some problem in economy or things like that. So it's a conceptual and understanding question, not much math behind it. Now let's go to question number 2. So what you need to do for part A, what you need to actually do, you draw this scatter plot with a scale, right? With a good scale. That is the key. So now you look at x values from 2.6 is the lowest and 4.5 is the highest. So make 2.5 up to 4.5 and 3.54. I mean, my scale was not good, so say 3.5, 4, 4.5, like that. And with the y variable, again 3.9 the lowest and 11 point something. So it's better to take 3 is much better, 3 to 12. So break it nicely into a good scale, otherwise you don't see it, and then draw your dots and see whether it gives you a line like this or line like this, or there is no correlation, it's going all over the place. So depending on that, you answer that question. Part B, verify that. Well, that's pretty easy because its answers are given, you just need to verify. So what I want you to do, make a table like this. Right, so these x and y values are given, just fill them, and then whatever the number, right over here, let's call sigma. That means you add all these things. So you add all these things, this is going to be sigma x equals, write that value. You add all these things, that's going to be sigma y, write that down. Similarly, this is sigma x squared, this is sigma y squared, and this is sigma xy. So find those values, right, and write those down because you need that for your next one to compute R. And by the way, these questions number 1 and number 2 are from 9.1 section. So you can look at the slides. Of course, you will have to not just look at the slides, you will have to read the books because the slides are good, but sometimes I feel like the last few slides are well, maybe you need to read the book as well. Okay, so the formula for R, you can look at it, you look this in your slides, but let me write it down. N sigma xy minus sigma x, again parenthesis is important, sigma y. You know what, let me write this down here so it's much easier for me to explain. So R is n times sigma xy minus sigma x sigma y divide by square root n sigma of x squared minus square of sigma x. Now you have to be very careful with this parenthesis. So I suggest you writing down this equation very carefully before you work this. Minus square of sigma y squared. So let me clearly explain. So sigma xy, that means this guy. Next, sigma x, sigma y. So this and this. In the denominator, that means under this line, n times, n is the number, x sigma x squared. So this guy minus sigma x everything squared. So that means whatever you got here, that value squared, right? And the same thing goes with this. So that's a careful little application of that. Okay, see, I'm helping you with the technical details only, right? You will have to read and understand again. And part D, well, you can answer that. And let's go to, yeah, this one. What do we have to do? Expected frequency. Well, again, that's that question is from 10.1 actually. So 10.1. So third question was from 10.1. So E is going to be expected frequency row total times column total divided by sample size. So it's pretty easy. Row total, that's, well, you have to do this for each cell. So how many cells are there? See, 1, 2, 3, 4. So 4 answers. For example, cell 1, you are going to get row total 47 times column total 41 divided by this number. Similarly, you do the other 3, okay? Okay, now let's have a look at 5.2, because 5.2, this question is exactly same as 5.1 question number 1, correlation question. So I don't need to explain that again. Let me show you. See right over here, exactly like that. And this one again, that is exactly like 5.1 question number 2. Let me show you. See sigma x, sigma y, all those stories. So I only need to explain you question number 3. Now for this one, first of all, this is a question from 10.2. So you will have to read 10.2. And then the first question, so read this story, okay? First question, what is the level of significance? And it's given, right? So it's pretty simple. And null and alternate hypothesis. So you have to state it down, please read it though as a sentence. So you'll have to say whether these two samples, two distributions, agree or disagree, things like that, right? Please do some reading. Let me help you with the technical stuff. P chi-square statistic. Now for that, chi-square statistics is actually sigma O minus E squared over E, where O is the observed frequency and E is the expected frequency. Now I recommend you to actually, you know, in 10.2, read this example. Read this example. So this is very much similar to the example that you have to work. See here you have the solution, and actually you will need this as well. K is number of categories, and degree of freedom. Normally we denote it by df, degree of freedom. That's going to be k minus 1. You will need this. Yeah, you'll need all of these things. So please read. See, these are the null and alternate hypotheses. So you can answer your question while comparing this example to your question. And also you will need table 7. I will show you in a minute. So please read this example because it's worked out. First read it and understand, and then you can do your, see, degree of freedom is k minus 1. Now let's go to your question. So find the value of chi-square, and let me write it over here, then it's easy. So chi-squared, chi-squared sigma O minus E squared divided by E, right? Give me a second here. Yeah, now here O is observed frequency. So for example, here sigma, that means you have to add many values. So you have to find this for each of these. So actually 1, 2, 3, 4, 5, 6 of them. So now let me go over here. So you will get one value plus some other 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 value. So each of these values are these guys. So for example, now let me explain here. O is, for first one, O is this 88. What is E? E you actually can find. See, 519, 12% of 519. So for this guy, E is going to be 519 times 12% of 0.12. And that's going to be 62.28. I cannot write here. So 62.28. That's going to be the number here. So 60. Oops, why can't I write? I don't know, for some reason I can't. Yeah, so now let me explain that. For some reason my pen got stuck here. So that's how you find that. And degree of freedom is k minus 1. So k is number of categories. And then give me a second, guys. Here my computer got stuck. Okay, I think I'm back. Let me see. I'm sharing. Yeah. No. So that's how you find chi-squared, and then degree of freedom, that's k minus 1. That's easy. So are they greater than 5? Yes, I mean, you can easily find these, whether all these values. That means those values you found over here, are these things greater than 5? That's the theory part, right? And if so, part C, find, estimate p-value. Now for this one you need table 7. So table 7 is in your book actually over here, right here. See this table 7. Now for example, if your degree of freedom, that's easy, pretty easy, because you have 6, so that's going to be 6 k minus 1 5. So for example, in your table degree of freedom, see right over here, so 5, you have to look at, see where the cursor is 5, and look at these values. What you need to do, whatever you got for your chi-square, that total value, look for that value. For example, if it were 0.7, see it's between, no, 0.7 and degree of freedom was 6, it's between right here, right? So for that question, your answer should be P is between some value and some value. And that's enough for that, because in order to find actual value, you will need some calculators, but you can leave your answer like this. That's fine by me. And then it's about it's about interpreting based on your answers. For example, if the p-value is less than significance level, then you reject it, otherwise other way around. I think that's enough hints for these two, and I will give you more for 5.3. Thank you.